Good day, students. Welcome to math.serve.com, and this clip we're going to be going over how to graph transformed exponential functions. Alright, so the instructions for the problem we're going to solve is as follows. So we're just going to be taking a look at one example. For the function f of x equals 3 to the x, we're to find the function y, which is given by f of negative x plus 2 minus 1. Okay, after we are done carrying out this transformation on the function, we are to describe the transformations, and then we are to graph. After we're done graphing, we're to find the domain, range, asymptotes, intercepts, and end behavior. Okay? Alright, let's go ahead and get started. So we're going to start off by looking for the function y. The starting function that we have is the parent exponential function, f of x equals 3 to the x. So let's figure out what y is. Y is given by f of, now let's color code this so you can see exactly what's going on, f of negative x plus 2. So we're composing the parent function with negative quantity x plus 2, and then we're subtracting 1 from the parent function. Okay, so if we apply this transformation to this function, what we're going to have is y equals 3 raised to the what power? Since it's being composed by negative x plus 2, the exponent here, x, becomes negative x plus 2. So we have negative x plus 2 as the power, and then minus 1. Alright, so this is the resulting function here. Now what we're going to do next is we're going to go ahead and proceed to describe the transformations on this function. Okay, so let's put the transformations to the left side here. Let me partition my workspace first. Alright, so our transformations are as follows. Transformations Alright, let's start with the shifts. What kind of shifts do we have in this function? In the transformed function, we have x plus 2. Okay, so x plus 2 basically means you're going to shift 2 units to the left. Remember, when you have x minus h, whatever transformation is grouped with the x, you always do the opposite of what the sign says, okay? So we're going to shift 2 units to the left, and then this is our plus k value. This is going to be 1 unit downwards. Now how about our reflections? Are there any reflections in this problem? What we're looking for is the negation of either the function as a whole or negation of x. We have the negation of the quantity x minus 2 right here. So this type of negation is a reflection in the direction of the y-axis. It is a horizontal reflection. So the reflection here is a horizontal reflection across the y-axis. Okay, so just as some slight details to remember, to keep in mind to help you understand what's going on. You have to remember that if you have something like f of x minus h, this is a shift h units to the right. Okay? If you have f of x plus k, this is a shift k units up. And then if you have f of negative x, in this case you reflect horizontally across the y-axis. Okay, and then if you have negative f of x, in this case your reflection is going to be vertically across the x-axis. So in this particular case, we have the negative is inside the function here. That's why we're reflecting horizontally across the y-axis. Alrighty. Now let's go ahead and sketch the graph of our transformed exponential function. Now this is going to be a sketch. We're just going to be making use of the intercept and horizontal asymptote in our sketch. Okay? Alright, so let's go ahead and graph the horizontal asymptote first. For all exponential functions, we have a horizontal asymptote due to the left-hand behavior. We have a horizontal asymptote of y equals 0. So let's go ahead and graph it right there. There's your horizontal asymptote. Let me change the color to green. Alright, so there goes your horizontal asymptote. Now, we're going to go ahead and graph the y-intercepts. Okay? Something you want to keep in mind is that the y-intercept of all parent exponential functions are identical. Okay? So that's something to keep in mind. So what is this identical value that I speak of? So I'm going to show you in a second. Let's have that down. 1, 2. Alright, the intercept, the common y-intercept that all parent exponential functions have is 0, 1. So there goes the intercept right there. How is that possible, or why is that the case? If you have y, let's change the color into a different one. Let's say you have y equals a to the x, and you want to look for the y-intercept. That's y of 0 is simply going to be a to the 0, which is just 1. So that's why the y-intercept of exponential functions of this form, the parent form, is 0, 1, as we have here. Alright, so let's go ahead and sketch the graph of the parent exponential function. So we know the general behavior of an exponential function. To the right, it just increases at an increasing rate. And then to the left, it just decreases towards the horizontal asymptote. It gets infinitely close to this line, but it never touches or crosses it. Okay? So this is the function y equals 3 to the x. Now let's carry out our transformations. So the first thing we're going to do is carry out a reflection. If we reflect horizontally, this is just a sketch. We're going to have our graph looking like this. The portion to the right of the y-axis gets reflected to the left side, and then the portion to the right to the left gets reflected to the right side. Okay, so this portion gets reflected over there. Let's draw that again. So this portion gets reflected over here. Alright, so what do we have now? We have y equals, as a result of the horizontal reflection, we have 3 to the negative x. Okay? Now we are done with the reflection. The intercept remains unchanged. This point is still right there at 1, 0, because it's right on the mirror of reflection. I'm in 0, 1. So now what we're going to do is do the shifts. Okay? So we're going to shift 2 units to the left. So we're going to just shift the point, this point, and the horizontal asymptote, okay? 1, 2, 2 units to the left, and 1 unit down. Bam, it takes us right to the x-axis at the value of -2. Okay? How about our horizontal asymptote? When we shift our horizontal asymptote uh, horizontally, because of its infinite length, there is absolutely no change. Okay? But when you shift it vertically down 1 unit, it's going to take us down to -1. So let's go ahead and graph that, the horizontal asymptote after the transformation. So it's going to be right here. Okay? Now, can you see what the line looks like? It's like this red line that we have right here, but it's intersecting this point, following the same pattern. So let's go ahead and sketch what the graph looks like. So we have on the right side, this is the final product, so we can make it solid, right? It gets infinitely close to the horizontal asymptote. It doesn't touch across it, so like that, going on forever. And then to the right, it just takes, to the left, it just takes off going up. Something like that. You have something like this. Alright, so that's the final product. And the equation of this line is y equals 3 to the negative x plus 2. The x plus 2 is because of the shift 2 units to the left, minus 1, shift 1 unit down. Okay? So that's the graph of the exponential function. Alright, so let's go ahead and start finding out, writing down some of the properties of this function. The first that we need is the domain and range, the dimensions of our graph. Okay, so start with domain. So our dimensions. The domain is how wide is the graph. What is the horizontal span of the graph? So it goes from -infinity all the way to infinity, because this graph keeps getting wider either whether you go to the left or to the right. Another way you can write this is all real numbers for the domain. How about the range? The range is the vertical span of the graph. How high can you go and how low can you go? In this graph, you go as low as -1, and then you ascend as high as infinity. Or you can write this as y is greater than -1. The next thing we need to find are our asymptotes. If you take a look at the graph, you can clearly see what our horizontal asymptote is. The original y equals 0 shifted 1 unit down. So our horizontal asymptote is going to be y equals 1 or -1 because it's shifted downwards. How about our vertical asymptote? Remember, our vertical asymptote is the same thing as our infinite discontinuities. This function is defined for all x values. You do not have any kind of discontinuities happening here. So this graph is continuous and hence has no vertical asymptotes or infinite discontinuities. Alright, let's proceed to find the intercepts. Alright, we'll start with the y-intercept. So if you want to look for the y-intercept, what you have to do is you're going to set the x to 0, set x to 0, and solve the resulting equation. Okay, so let's go ahead and do that. We have the y-intercept, and let's write down the original function. The original function is 3 raised to the negative x plus 2 minus 1. So your y-intercept will be y of 0, basically evaluating the function at x equals 0. So we have 3 minus 0 plus 2 minus 1. Alright, let's simplify this. We're going to have this becomes 3 to the negative 2 minus 1. Now, using the reciprocal property of exponents, we can rewrite 3 to the negative 2 as 1 over 3 squared minus 1 over 1. Simplify further, we have 1 over 9 minus the LCD of 9 and 1 is 9. So 1 over 9 minus 9 over 9. And then the answer is going to be negative 8 over 9. Our y-intercept is negative 8 over 9. Or if you plug in the calculator, if you plug that in the calculator, is equivalent to, so the approximate form or the decimal form of negative 8 over 9 is negative 0.8 repeating. Okay, and that's right here on our graph. Let me illustrate that for you to see. Right here is the y-intercept, which is negative 8 over 9 or negative 0.8 repeating. Okay, now how about our x-intercept? Let's look for that. Our x-intercept can be found by basically doing what we did in reverse order. So instead of setting x to 0, we set our y to 0 and solve the resulting equation. Okay, so the graph that we have, the function is y equals 3 to the negative x plus 2 minus 1. So we're going to set y to 0 to get to figure out what our x-intercept is. So we have 0 equals 3 to the negative x plus 2 minus 1. Alright, so we add 1 to both sides of our equation. Can switch our equation around, so that gives us 3 to the negative x plus 2 equals 1. Alright, so we need to power down this exponent. In order to do that, we can take the logarithm of both sides. So we're going to take the log of both sides. So log of both sides of our equation. We're going to use log base 10, so we can plug it into the calculator real quick. So the common log of negative x plus 2 and a common log of 1. Okay? So now we can power down this exponent to yield, so this exponent can get powered down. It's going to be negative quantity x plus 2 log 3 equals log 1. And then we can divide both sides by negative log 3 just to get the quantity x plus 2 by itself. Alright, if you plug that into your calculator, log 1 is 0. Okay, so if you just put that in your calculator, you have x plus 2 is equal to 0. Subtract 1 from both sides. Subtract negative 2 from both sides, and that will give you your x-intercept. Your x-intercept is negative 2. And you can see that in the graph that we drew earlier. You have an x-intercept of negative 2 right there. So your x-intercept is negative 2. Alright, now let's look at the end behavior of our function. So the end behavior is as follows. End behavior, we have the left and the right end. So for the left end, using the limit notation, the limit as x approaches negative infinity of the function, if you look at the graph, you notice that the graph is going up, is rising. Okay, so since the graph is rising, the left end behavior is infinity. How about the right end behavior? That's the limit as x approaches infinity of y. So if you look at the graph, what you notice is that the graph is flatlining towards a particular y value, namely -1. Okay, so our right end behavior is -1. All right, so that's that. Thanks so much for taking the time to watch this presentation. If the contents of this tutorial was helpful to you, do give us a thumbs up. Don't forget to subscribe to our channel. More tools can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.